and then feeding that extra fodder to the livestock. But a key there was minimizing the workload on those women farmers, often who, during the active growing season, are working 18 hours a day. A big part of the labor inputs to those cropping systems is the preparation of the field to be planted. It's backbreaking work. It's all done by hand, and you're planting these vulnerable seeds. If you don't get the rain just right in the right time, or if you get too much of it, that little seedling will fail to establish. He wanted to take some of the uncertainty of that out and grow perennial. This is a second-year perennial wheat hybrid that he's sitting beside. Still needs some work, but it shows some of the promise that we can imagine. More stable grain and biomass yields, take out some of the variability. And also on the nutrient, those landscapes had been farmed for very long periods of time. Few of the micronutrients are returned. You can't just apply very expensive fertilizers in these challenging circumstances. So tapping into those deeper soil resources for improved nutrition. A side benefit that he had not expected was that the crossing of these wild hybrids with the annual crop introduced some new disease resistance pathways. Yellow rust in that region is an awful thing, wipes out crops. And new improved wheat varieties that are resistant often break down, but this introduced some new pathways to resist this yellow rust. So whenever I talk about perennial grains, I get a few frequently asked questions, or actually concerns, I think. We're approaching 9 to 10 billion people that will have to be maintained. Can perennials do it? And then we also think, one of the benefits of an annual crop is that they're fairly short-lived. So if diseases come in, they get their seed produced, you harvest it, and then it doesn't matter if it dies or not. So aren't perennials essentially sitting ducks for disease and pests? Won't they build up over time? And then